So finally, let's have a little look at the application layer. This is the final part of how our, our website loads. So the application layer, we can demonstrate that using a tool called curl. So curl is a C URL. It basically loads a URL using a C library. So what I've got here is a command curl dash dash verbose https colon slash slash jtucky.name. And now I'm going to pipe that into head, and I'm going to say I only want the first 50 lines of output. This website is actually going to generate quite a lot of text, so I don't want to see everything. I just want the first 50 lines. That'll give us a good demonstration. I've started up my packet capture here as well, so let's run this curl verbose. Okay, and we get a whole bunch of data out. Excellent. I'll scroll up a little and we can have a bit of a look around. Cool. So here's where our command started. Now let me also stop the packet capture at this point. So we see what we've seen before, the outgoing connection, a SYN connection, SYN ACK, an acknowledgement. Okay. Now, this time we see our first data packet. So we see our first data packet going out, TCP, we've got the push acknowledge, and now we're seeing inside of this data packet our transport layer security. So we see TLS 1.3, record layer, handshake protocol, client, hello. Now what is this? Well, as I mentioned earlier, this is going to be a TLS connection. So the first thing that my client here, curl, sends over the connection is a client hello. So it first of all makes a TLS connection to the server. This is in that data layer, and it establishes a TLS connection. So TLS secures the connection. No one else on the connection can actually see the data that I'm sending to and from the server. Once it's established that TLS connection, it will then perform HTTP requests over that TLS connection. So we see our client hello here. We see an acknowledgement back from the server, and the server sends us back some data as well. The server sends us back a server hello. So it says, okay, I saw your client hello, and I'm sending back a server hello. It says some details about the connection, the handshake protocol, the TLS version, the cipher spec that it prefers. This information is all available in the TLS Wikipedia page. But effectively what it is saying is, okay, I see you've made a valid client hello instead of that garbage hello we sent before. And so, yes, let's establish a connection. We send back an acknowledgement, and the server sends us back some more data. And now this time what we're seeing is just application data, right? We see TLS, application data protocol, HTTP over TLS, and just encrypted application data. We send back an acknowledgement. We get back more data, more data, more data. We get back a lot of data. And now as this goes down, we will see many application data. The server is sending us a lot of data. We just keep sending back acknowledges and just a little bit of application data back. And then some acknowledgements go back and forth. And then there's just a continuous data stream from the server. And if we look at the packets, you can see the server keeps sending us 1,500 byte packets, and then we acknowledge them, and that carries on through the whole connection. At the end of the connection, we see this reset packet. Now, this is a different type of flag from what we've seen in the past. So a reset packet is sort of like a thin packet, but it basically says, I am resetting the connection. And you see there's a whole bunch of sort of garbage data here at the end. We're not going to have a look at that. The Basically what's happened is the the connection was running, but because I piped it into head, the curl client failed to write out all the data, and so it disconnected the server actively. And as you can see, curl failed writing the body. Yeah, it errored basically. That's not a problem in this case, but you do see all that sort of reset. Now, one thing I'll point out is that from the start of this TLS connection onwards, we actually can't see any of the actual data. We just see these blocks of encrypted application data, and that is what TLS is providing for us. Big blocks of encrypted data that we can't decode. And this is a good thing. It protects the connection, but that means that to actually see what's in the data, we need to use the actual tool that made the connection, the secure connection, to decode the data. So from now on, we'll have a look inside our curl connection here. So you can see the negotiation of the connection in our terminal here. There's a whole bunch of information. And then we see that curl sent out a TLS handshake client hello. It received back a server hello. So this actually matches up with the client hello and server hello that we see here. It sends out a TLS handshake, some encrypted extensions, gets a certificate verify, finished. Curl here is validating a fair bit of the information and making sure that the TLS connection is established correctly. And you can see that eventually it did establish a secure TLS connection, TLS version 1.3, and then there's the TLS cipher spec that it's using. It also has a server certificate, and you can see that the certificate has a name, autodiscover.jtucky.name, but there's also an alternate name on the certificate, jtucky.name, which matches. It's verified by Let's Encrypt, and the certificate is verified okay, so my server believes that this is really the server it should be talking to, and it trusts it. It also is using HTTP 2, which is the newer version of HTTP, and there's some more information there about the connection. And then at this point, we reach the end of the connection negotiation. So this point here is the end of the connection negotiation. So from this point on, what we're looking at is what is inside the connection, inside the TLS protocol. And so what we actually send to the server is this data here. We send a GET request to / we say that we're talking HTTP version 2. The host that we are looking for is jtucky.name. Our user agent is curl version 7.68.0. And we accept all encodings and types. The server sends us back some data. It says, okay, I'll talk HTTP2 to you. The return code is 200. This is a successful request. I was able to find what you're looking for. It sends back just some information. We're powered by PHP. The content type is HTML and it's encoded as UTF-8. There's a link information, an e-tag, some other details, a date, a server, alternate service details. This information just contains a whole bunch of extra information that my browser, if this was a browser, could use. And then at the end, we start to see the actual HTML. And we see, doc type HTML, title, jtucky's blog. Okay, so this is good. We've almost made the connection that we were making at the very beginning. Now I'm just going to rerun this connection with a slight change. So I'll restart the capture. And this time I'm going to do it with /about. Now, if you recall at the beginning, what we actually wanted to fetch was the about page. So I'll run that again. And, we've got to scroll back up through an enormous block of text. Okay, so this is the connection that we are making. We can see here all the packets that flowed. I'll stop the capture. We again make a connection to the server, we send the client hello, get back the server hello, and then we pass a whole bunch of data back and forth. And at the end, we have the fin packet and the acknowledge packet, and the server is all disconnected. There's also some reset packets. I'm not 100% sure why, but basically at the end, we sent to the server that we were acknowledging that this was a final connection. We set the fin packet, so the fin flag, we're closing the connection. Now, all this is still going to the exact same port and, over the same protocol. So what did this /about actually change? How does it know what our page we're actually loading here? Well, if we dig through this curl verbose connection again, we've got some more information there again, but this is the important thing. So when we send to the server inside our encrypted connection, we say get again, but now we say that what we're fetching is the /about page. And, it's still the same host and stuff, but the server then can actually look at this get request and know which page to serve. So that's sort of all encoded in the data. And then it sends back, a bunch of information. So HTTP connection, some links and some other useful information. And then it sends back the actual page details. And you can see this time the title is about me. So we actually got back the correct page. We got the title back rather than the the top level page, which is what we fetched the first time. So now we've successfully loaded that title page.